Okay, good morning, students. I hope you can hear me this time. We're looking at multiplying ugly polynomials and complex numbers. And our first method, and really the only method we're going to go over today, is the box method. Double distribution, I will show it once, but it's not my favorite, and we've already learned it. So what I love about the box is you can do it for any problem type. And we look at the original problem. This is x plus 4. So that's 2. That's a binomial. That's why we have 2 here. And I set it up as x and then plus 4 on the side. And then the other part is the trinomial. So I set that up as 2x squared minus 3x and then plus 7. And you can very clearly see, oh, I have to multiply 6 times. And that's really nice to know. So I'm going to multiply across. And in the first box, I'm multiplying the x and the 2x squared, which gives me 2x to the third power. Multiplying by x just makes everything one more powerful. So that'll be minus 3x to the second power and then plus 7x. When I multiply that bottom row with the 4, it's just going to change the coefficients. That's going to be 8x squared minus 12x, and then plus 28. Another thing that I like here is that usually the diagonals are like terms. So I have two problems in standard form, meaning they go in power order 2, 1, 0 for the exponents. And then of course 1, 0 for the binomial. And when we have problems like that, that creates diagonals that are like terms. So you see the 8 and the -3, they both have x squared. So that just means we're going to add those together. Then here, the 12 and the 7 both have an x. So we also add those together to get our final answer. So the final answer is 2x to the third power plus 8 take away 3, 5x to the second power. We keep the variable term the same when we're adding. So -12 and 7, we add those and we get -5x. And then plus 28. This is our final answer. So if we don't have a problem in standard form, those diagonals won't be like terms always, but I just love this box method. Let's take a look at double distribution, just very briefly. So when we double distribute, this is what we've done historically. This is how foiling works, but we're kind of showing the behind the scenes. So we first write that first term, 7x, and then space -9. And then in the space, we're going to put in the other expression using parentheses. 8x plus 6, and then again, 8x plus 6. And then we just distribute. We're doing the distribution property twice, and so that's why it's called double distribute. This one's a great one to practice your trickier multiplication tables. 7 times 8 is 56. X to the second power. 7 times 6 is 42, so plus 42. X. And then with the -9, I'm distributing the negative. So it will be -72x and then -54. I have like terms here in the middle, so I add those together to get my final answer of 56x to the second power minus 30x minus 54 as my final multiplied out, in this case, quadratic trinomial. So you can always use FOIL for multiplying binomials, or double distribution could technically be used for multiplying those larger problems. But like I've said, I prefer the box method just because you're less likely to make mistakes. Now, when we're using multiplying complex numbers, I use the box method every time. And we need to keep this hint in our mind. So let's start with this first problem. So I'm going to create the box and I'm just going to go like this. And then I'm going to say 3 minus I. So now I've already got the box. You see the 2 and the 10 already set up. So when I multiply across here, I've got -6, and that'll be 3 times -10, so -30i. Then multiplying the negative I, that will change this to +2i. And then a negative times a negative again, 10i to the second power. So I'm going to show my work on this I to the second power. This means 10 times I to the second power is equal to -1. So that actually just results in this total expression canceling out and just becoming -10. So the I squared changes the sign. Now what we have are like terms on this diagonal and like terms on the other diagonal. So we have double diagonal like terms. So the box method is 100% the best method for multiplying complex numbers. So -6 and 10, we add those together to get -16. And then 2 minus 30 is -28i. Remember, when we're adding, we don't change the exponents. So this one is awesome. We did a great job here. Let's do it again with the next problem. So I'm going to have 8 and then the 3i. And then I get 64. Multiplying, I get -56. And then I get 3 and 8, 24i. Oh, I forgot my I. Sweet. I know that the diagonals are like terms, so I'll put that I back here. Then 3 times 7 is -21i to the second power. The I to the second power has the result that it changes the sign. So this is going to change to +21. And now I can add my like terms on the two diagonals. 21 and 64 is 85. And then 24 minus 56 is going to be a negative 32i. So the last one is for you to try. Go ahead and give it a whirl. Set up your box. It looks like I wrote that too close to the bottom, so you might have to set up the box all by yourself. I'll set it up over here quietly. Hopefully you got 43 plus 202i like I did. If not, you can see my work. And that's it for multiplying these ugly polynomials.